Okay, this video is going to walk you through how to factor a quadratic just like we learned in class. So the instructions here state to completely factor each of the following quadratic expressions, clearly state your factors by writing the area as a sum equal to the product. So what that means is this here would be considered area as a sum. And we talk about this as area because we can set up area models in order to multiply the two factors together to give us the area as a sum. So this would be the area as a product, which is what you are going to find. So normally I would give you the area as a product, which is called the factored form of a quadratic. I would give you the factored form and you would have to tell me, okay, well then what is the area as a sum? Like what if we multiply this all together? But now you were given the area as a sum and you were asked to find the factored form. So here's the first thing I do. I write out the expression. And I know that I'm going to need to multiply my first and my third terms together to give me the top of my diamond problem. So the diamond problem is going to look like this with that one on top. And then we know that the one that goes at the bottom is the bx term because we're trying to split that up in order to still have the same product diagonally. And I'll show you guys what that looks like in just a moment here. So this one always goes on the bottom. Now the reason why it looks like this is because if I were to set up my area model, like so, we know after our class lecture that the first term, which is the ax squared term, always goes in this first box here. This is always the ax squared term. And in this case, it's only x squared. Its coefficient is a 1. No 2 or 3 or 4 or anything. It's just a 1. And then our c term, so this is the c term, our c term goes in the bottom right of the area model. And again, you guys could have put like x squared here and the c there, but I like to keep it consistent, and this is how I've consistently done it in the past. So now we have almost all of our little setup here. And just to remind you, the reason why it's negative 12x squared on top is because we multiply these two together, and that is our diagonal. And so whatever this product is also equal to that diagonal's product. So that was the little thing that we learned in class, is that if the area model is set up correctly, then the diagonal products are equal to each other. So whatever those two numbers are in that bottom left and top right, they are also going to multiply to negative 12x squared. So we have to see what those two numbers are that multiply to negative 12x squared, but also add to negative 4x. Once we find those two numbers, we're going to put them right where the purple is there in the area model, the bottom left and the top right. So we basically need to find all the factors of 12, and this is a negative 12, and the bottom is also a negative. So we have to keep that in mind. But first, let's just see the factors of 12. We have 1 times 12, 2 times 6, and 3 times 4. We could keep going on 4 times 3, then 6 times 2, but it's just repeating itself. So really, we're all good to go here. So now I want to look at that and see, okay, I know one of them has to be a positive and one has to be a negative because our product is a negative. The only way to get that is if you multiply a positive times a negative. So here, I know I'm going to have a 6x and a 2x. That's the only way that I can get 4 somehow. And in this case, it's a negative 4. So that means that my 2 must be positive because 2x minus 6x is negative 4x. So this is where those diamond problems really come into handy, and you have to get really good at them. So here, it does not matter which one I put where. They just both have to be in the box. And then if you check it, 2x times negative 6x is negative 12x squared, just like the diagonal of x squared times negative 12. So now we're at the point where we need to factor. We need to factor out the GCF. So that is the greatest common factor, GCF. That's our first step. So if I'm looking at this side of the area model here, x squared and 2x both share an x. So I'm going to go ahead and write x here. And then I know, okay, well, x times something must equal x squared. The only way I can get x squared is if it's x times x. And then here I know x times something equals 2x. It would be a 2. And then over here, I'm looking here at the GCF between them, but also what do I multiply x by to get negative 6x? Or what do I multiply 2 by to get negative 12? In each case, the answer is negative 6. So these are our factors. So now we have x plus 2 times x minus 6. And again, you could have written the x minus 6 first. It does not really matter. But this is the factored form. Now eventually we're going to take the factored form a step further and find things such as the x-intercept from the factored form of a quadratic. Remember, a quadratic is a parabola. Quadratic functions have some variable squared, so like x squared, and then they create a parabola on a graph, facing up if they're positive or down if they're negative, so it just depends. Okay, so here's the next one, and I'm going to start going just a little bit faster, so make sure you're keeping up the best you can. So I'm going to first draw the area model. Okay. Go ahead and move that down a little bit. All right, so the first thing I like to do again is put the ax squared term here. So this would be 4x squared. And then the c term will be here. Okay, so now I have to look and see, okay, if I multiply these two together, I'm going to get 4x squared. That's the same thing as just multiplying these two, right? They're the same numbers. And then I have my diamond problem. And I have to put my 4x at the bottom because that is what I'm splitting up. I have to split up that bx term. So this is 4x. So now I need two numbers that multiply to 4x squared but add to 4x. So my factors of 4 are 1 times 4 and 2 times 2. So the only way that I can get two factors that multiply to 4 but add to 4 as well are if it's 2 and 2. So right here, these are going to be my factors here and here. 2x and 2x. I guess I should have mentioned as well, if you guys notice here, we have a 4 in the front of the x squared. I should have checked to make sure that 4 is not a GCF of this entire equation here. So what you could do always, your first step, is to see, is there a GCF? If there is, then you have to make sure to factor that out before you go through the method of factoring, like so. Okay, so then the second step would be diamond problem, or I'll just leave it as diamond and area model. Those are the things you need to do. And now we're at the step. Now that those two things are done, we're going to factor. So here, 4x squared and 2x, their GCF is 2x. They're both divisible by 2 and an x. Here, these are also, they also have a GCF of 2x. 2x times something equals 2x, so that must be a 1. And again, 2x times something equals 2x, so that also must be a 1. So here we have our factored form is 2x plus 1 times 2x plus 1. We could also rewrite this as 2x plus 1 squared because it's being multiplied by itself. So either of those two would be correct answers here. So remember to pause the video if you're needing help. If you need to step back and try to do it on your own again, give it a shot. Okay. Here we have 2x squared minus 9x minus 5. So first I want to check, is there a GCF? Somebody might instantly think, oh, it's 2. But each of these are odd numbers and neither one can be divided by 2. So we cannot do that. So there are no GCFs. No GCFs. None. Okay. So the second thing we need to do is set up the diamond and area model. Okay. So I always get into the habit of just multiplying A times C, and that's always going to be the top of your area model. Just because if I were to draw my area model first, it's going to be the same thing. So if I were to draw that, again, my first term, my ax squared term, is going to go on the top left, as this one is, this one is 2x squared. And then the bottom right is going to be negative 5. And 2x squared times negative 5 is negative 10x squared. Okay, so it's the same thing. And then on the bottom here, we have the negative 9x, because that's what we have to split to figure out what needs to go inside of the box, because they must have combined those like terms before, right? So negative 9x. So if I set up my factors for 10, 1 times 10 is 10, and 2 times 5 is 10. And that's pretty much it. So I know that one of them must be a negative in order to give me a negative 10, because a positive times a negative is equal to a negative. So whatever we do there, we also have to make sure that it equals negative 9 when combined by addition or subtraction. So in this case, the 1 and 10 are the only things that could get us a 9. It would have to be 1x minus 10x to give me negative 10x squared as the product and negative 9x as the sum. So those two are our factors of this diamond problem. You multiply those two together to get the top number. Okay. So here, does not matter where you put it. I'll just put 1x here and negative 10x here. And now you want to try out factoring, and please be sure to be pausing the video and trying this on your own, okay? So here, the greatest common factor is going to be 2x. And then this one is just x on the left here. They only have x in common, and it works to multiply it. This one on the bottom, they both have negatives, so the negative gets pulled out, and they're also both divisible by a 5. And then on the right there, those two are only divisible by 1. That would be their GCF. So here, our factored form now is 2x plus 1 times x minus 5. And we're done. That one is all done. That is your factored form. So be sure to pause before you move on to the next question. Oh, I forgot to write our third step is always to factor. I just forgot to mention it. Factor, okay? All right, so same thing here. Again, my habit is that if I have my ax squared and I have my c, I multiply them right away. So this would be negative 24x squared. And then I set up my diamond problem. You could always set up your area model first. It's totally up to you. I kind of do them at the same time sometimes, you know. So like that one is part ways done. I'll go and write the 10x here. And then I'm like, okay, I want to set up my area model now. So it's ready. So I mean, it's totally up to you, whatever order you want to do these two things in. So the top one is 3x squared. The bottom right one is negative 8. So just remember, I'm going to color code again. So the top box is always, for me, how I do my problems, I always put the x squared in the top left box. And then I always put the c term in the bottom right. Those always have to be diagonal no matter what. No matter what. Okay? And again, if you multiply these together, you're going to get negative 24x squared. So we need to find two numbers that multiply to equal a negative 24x squared and a positive 10. So here, our factors of 24 are 1, 24, 2, 10, 3, 8, 4, and 6. And then it starts to repeat 6 and 4, 8 and 3, 10 and 2, all of that. Okay? So now looking at this, somebody might instantly say, oh, 4 and 6. 4 plus 6 is 10. But positive 4 times positive 6 is not negative 24. So that's not going to work there. So our next best option is the 2 and the 10. 2 and the 10. So here, the 2 and the 10, if they're multiplied together, right now they're both positive, but if they're multiplied together, one of them needs to become a negative. Oops, I'm so sorry. I knew I was making a mistake. I am tired, guys. 12. That should be a 12. I was thinking about how it has to add to 10. All right, sorry about that. 12 and 2 are the winning factors. I'll give you a second to get caught up there. I do apologize. But one of them needs to be a negative. Which one needs to be negative to make the 10 a positive? It's going to have to be the 2. 12 minus 2 is positive 10. Okay, so we're going to have a 12x and a negative 2x. This one looks pretty nice. So here, the greatest common factor is just an x. Right here, the greatest common factor is a 4. And up here, their GCF here is a 3x. I'm going to erase all these other scribbles here. Oops. So this one here is 3x. And now I can kind of check, right? 3x times x, 3x squared. 3x times 4, 12x, right? Oops, hold on. There we go. And then here, they're both negative. So negative and a 2. And again, you can check to see, okay, so if I have negative 2 times x, that should equal negative 2x, and it does. 4 times negative 2, yep, should equal negative 8, and it does. And so on. Okay? So now this one, answer, the factored form is 3x minus 2 times x plus 4. That's a positive 4 there. X plus 4. And you're done with that one. Okay. So here's another one. This one definitely has a common factor. Okay, so here, our GCF, which I forgot to mention before, our GCF here is 2. Each of these can be divided by a 2. So if I pull out a 2, right, if I were to divide the 2x squared by a 2, I'm left with x squared. And then if I divided negative 40x by a 2, I'm left with negative 20x. And divide 200 by 2, I'm left with 100. So now I have to simplify or factor just the inside, and that is it. So the 2 out in front can just stay out in front for now. And then in the end, at the very end, the answer here will be 2 times the product of binomials that we will get. Okay, so we are only going to focus on the inside. So as usual, x squared times 100, we multiply those two, 100x squared. Okay, and then again, I always like to put my bx on the bottom. So in this case, it's negative 20x. And I'm going to go and draw my area model. Okay, so again, the top left is x squared, and its diagonal is the c term. That is 100. Okay, so here is x squared, and the orange is 100. And you guys notice, right? I'm not messing with that 2 out in front at all. Like, it's done. It's already there for us. So, whoops, I forgot to write. This is negative 20x. Okay. So now I got to find two numbers that multiply to positive 100 but add to negative 20. So if I were to find all my factors of 100, okay, I have 1 times 100, 2 times 50, 4 times 25, whoops, 25, 5 times 20, let's see here, 6, 7, 8, 9, 10 times 10, that's a big one. Okay, and then if this one is negative, we know that it's either one of these answers must have a negative in them. And since we know that the top is a positive, if at least one of them has a negative, then the other one must also have a negative in order to multiply to be a positive 100. So it's going to be a negative times a negative, And it looks like the 10 is the only one that we can use here. Negative 10x times negative 10x is 100x squared. Negative 10x plus negative 10x is negative 20x. Oops. Did not mean to do that. I meant to do a highlighter. There you go. There you go. All right, so then this goes into your box, your area model. Okay. So here I have, this one will be interesting. Here I have negative 10x and negative 10x. Let's see what this one ends up looking like. For above the blue one there, the greatest common factor is an x. And for above the purple one on the right, that greatest common factor is a 10. Same thing over here. This is going to be x and a 10. And since both of the 10x's are negative, then both of the 10s have to be negative. And then negative 10 times negative 100 is positive 100. So then you're good to go. So our final answer here is x minus 10, or 2 times x minus 10 times x minus 10. Or you could also rewrite this as 2 times x minus 10 squared. Either way, either one of those would be acceptable answer. Doop, 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 doop. Okay. All right, let's see. Okay, so this is from one of the homeworks from Khan Academy. I think it's Hing. Hing was trying to factor 10x squared plus 5x. She found the greatest common factor of these terms was 5x and made the following area model. So basically here, guys, she knows that the greatest common factor is 5x multiplied by something is going to equal 10x squared plus 5x. Because the area is down below, right here, this is the area of that rectangle, and we are trying to find, okay, what must this width be? If this side is 5x, then how much is here inside? So here, what you really need to do is divide 10x squared by 5x to see what you would multiply by it to get 10x squared. So if we divide it by 5x, we're left with 2x and then plus 1, because we're also dividing this one by it as well. So your final answer here would be 5x times 2x plus 1, and you would write 2x plus 1 here in the answer box. I used parentheses earlier, and it marked me correct, and I believe I've used it without parentheses, and it still marked me correct. So as long as you get the right inside, you should be good to go. Okay, so now this one says the rectangle below has an area of x squared minus x minus 72. And we know that one of the factors is x plus 8. So it's talking about the length of one of the sides there. Okay, so if we have x squared minus x minus 72, let's go ahead and take a look here. If we multiply these two together, we're going to get negative 72x squared. Put a little diamond here. We know that the red is what comes over. So a negative x is a negative 1x. Okay, that's what it is there. So now I know I need to multiply to negative 72x squared, and I need to add to negative 1x. So I'm going to go and set up a nice area model. Like so. Okay. So there were no GCFs here, by the way, so that's why we went straight into factoring like this. So here, the top left, again, is the ax squared term, okay? So this one's going to be ax squared. In this case, it is the x squared all by itself. All right. And then the last one on the bottom right, whoops, I keep doing that. The last one on the bottom right is your c term, which in this case is negative 72. Okay, so that's what goes here. And then now you remember that the reason why this goes up top is because if we multiply the diagonals, we need each set of the diagonals to be congruent to each other. So that's why we have to set it up this way. Okay, so if I were to find all the factors of 72, right? 72 is positive, but the one, oh, I'm sorry, no, this is negative 72, right? So it's going to be a negative 72. So we have to think very carefully about how we set this up. So some of the factors, I always start with 1. 1 times 72. 2 times 36, 3 times 24, 4 times, let's see here, so that'd be 15, so 18. Let me make sure I did that right. Yeah, I did. 18, good. And then 6 does not go into it, my bad. Oh wait, yes it does. Yes it does. That would be 12. Sorry, 6 times 12 is 72. And then 8 times 9 is 72 as well. So here we have to figure out, okay, how can I add or subtract them in order to get something that is 1, or has a difference of 1, or a sum of 1. So here now, it has to be a negative 1, so we have 8x and 9x. So which one of these needs to be negative to not only multiply to this negative up in the product, but also to add it in such a way that our result is a negative 1. So hopefully you can see that in order for the result to be a negative 1, your 9x must be negative. 8x minus 9x. Okay? And 8x times negative 9x is negative 72x squared. So there, the two factors go here on the board, on the area model. And we want to put 8x and negative 9x. Again, it does not matter where you put them. Let me just go ahead and get this out of the way a little bit. Whoops. Okay, we'll leave that there. All right, so here, again, we are now at the step of factoring. So on the left here, x squared and negative 9x, that will be x is our GCF. X times x is x squared, so that goes there. Negative 9 times x is negative 9x. And negative 9 times 8 is negative 72 as well. Okay. So our width, right, they already gave us x plus 8, so we were missing the x minus 9 part. So you have to put x minus 9 into the box on Khan Academy. Okay, here it says again, factor is the product of two binomials, all right? So again, I'm going to go through relatively quickly. I'm going to go and draw my area model. It does not appear that there are any GCFs there, so we should be pretty good to go. So here in the top left, your ax squared. Bottom right, 42. Okay, negative 42 as well. I keep forgetting to say the negatives. X squared and negative 42. Okay, so here x squared, negative 42. Now, if you multiply them together, that would be the product of the diagonals of the area models. So this is negative 42 x squared on top. That's their multiplied. All over a negative 1. Because that, or I'm sorry, a negative 1x. Because that is our B term. And the B term always has to go on the bottom. Okay? We want to make a little chart. We have 42, 1 times 42, 2 times 21, 3 times 14. Okay. Not 4, not 5. 6 times 7, right, is 42. Hopefully I did that math right. Okay. So now if we look at these, there's only one possible combination that can get us anywhere close to a 1. It's going to be 6 and 7. Okay. So here for the 6 and 7, let me see here. We have to determine, okay, which one will give us a negative 1 if we make it a negative. So we know for a fact it's going to be 6x times 7x. So we need to be able to combine them to get a negative 1x and to multiply them to get negative 42. So here we have 6x minus 7x will give us a negative 1x. 7x minus 6x would have given me positive 1 on the bottom, right? So here what we want to do, we have our shadings here. We're going to have 6x and negative 7x. So now we can factor. The top left is going to be x, x, -7, and a +6. So look very carefully at how I did that before you move on to the next problem. All right, so this one I see that there is a GCF. It is 5. So what I want us to do is to factor out that GCF before doing anything else. Okay, so once we're able to factor out the GCF, which means we divide each of the terms by that factor, all that we'll be left with inside, so if we have 5 times, it's going to be x squared plus 5x plus 4. So now we need to factor the inside. And we're just going to leave that 5 up here because a lot of times we forget that we have a greatest common factor that we already pulled out, and it needs to be a part of our answer. It is one of our factors. We're just going to have 3 factors this time instead of just 2. So now if I do this like I normally do, x squared times 4, 4x squared, 5x on the bottom. I'm going to go ahead and color code that for you so you can see it clearly. Oh, actually, hold on, sorry. I have to color in my area model first. Okay, so the x squared term is going to go in the top left. The c term is going to go in the bottom right. It's going to be whatever the x squared term is from the one we're actually factoring. So here we're going to put x squared and 4 because that's what we're actually factoring. So we need 2 factors. We need factors that will multiply to a 4 but add to a 5. So I think of 1 and 4 or 2 and 2. This one's pretty straightforward. It's obvious that the only possible combination is 4 and 1. Okay. And then here we have to multiply to 4x squared and add to 5x. So this one is perfect, right? We have 1x there and a 4x here. So what that means is whenever I put those into my table here, let's see, putting it into my table, I'm going to have 1x and 4x, x squared and 1x, the greatest common factor is an x, so it is also an x here, a 4 is here, and a 1 is here. So your complete answer will be 5 times x plus 4 times, x plus 4 times x plus 1. Okay, and this would be our final answer. All right, so always keep an eye out for that GCF. All right, I think this is the last one for you, okay? So here we have another GCF, but this time our GCF is 4. Each of them can be divided by a 4. So this is going to be 4 times something that was factored, okay? So here, the first thing I do, once again, is pull out that greatest common factor. So I'm going to have a 4 out in front with x squared minus 7x plus 10 equals whatever we're going to get here. Okay, I'm not going to put an equal sign there. All right, so I'm going to set up my area model. Okay. So once again, we're only factoring what is inside of the parentheses because we already factored out the 4. We don't need to worry about that anymore. It is a factor. So this is top left, bottom right. So on the top left is going to be x squared. Bottom right is 10, positive 10. Okay, and we're almost there. So now we need to do the diamond problem. So x squared times 10, or x squared times 10, will be 10x squared. And then the bottom part will be the negative 7x. Okay, so now we need to find two numbers that multiply to 10, but will give me a negative 70x. or negative 7x. I apologize. So I know 1 times 10 is 10, 2 times 5 is 10, 5 times 2, and then so on. Okay. So here I have to see, okay, which one would I have done to get negative 7 as a combination, but multiply to a 10x squared. So I know if that's a positive and it's negative down below, these must both be negatives to somehow get me a negative down below. And it looks like the only one that's close to 7 is our, let's see here. The only one that we can get 7 with is 2 and 5. Right? And I would put the 2 first. So negative 2x minus 5x. Actually, it doesn't really matter which one you put first. I'm telling you guys, I'm like half asleep here. I'm just saying things. So it would be negative 2x and negative 5x. Negative 2 minus 5 is negative 7. Negative 2 times negative 5 is 10. X squared. Okay. So then here we have negative 2x and negative 5x. Okay. Once we do that, we are now able to factor. All right, so this column here, they both have an x. That is their greatest common factor. Okay, so this is going to be an x. And then over here, they both have a 2 in them where they can be divided by a 2. I think this one's going to have a negative sign in each of them, just a heads up. Whoops, whoopsie, I put 2 x's here. I don't know why I did that. That's weird. Okay. So then over here, I'm going to have x here. X will be here. X, and then it is going to be a negative 5. Okay. So here we have x squared minus 2x minus 5x plus 10. All right. And the factored form of that is 4 times x minus 5 times x minus 2. And that should conclude our video. So hopefully this helped you practice the skills of factoring. Please be sure to take really good notes and rewatch the video today if I've posted it. There are also plenty of other resources on the internet or anywhere else that you can also search this up, but please send me an email if you need any help, okay? Have a great rest of your day.